can lead a student to class, but I can't make them stay. Okay, anything else about that, or from homework?
There was a problem, number 5 or so, I'm not sure. But it was negative 5x, whatever, negative x squared, 5x squared minus negative 5x squared. Is it negative, positive? I can't think of it, but I don't know if I should have added or subtracted to
Anything figure out what the question is? You look at yours, okay.
yeah.
What was x to the 5th over 2x to the negative 2? Or
Yeah.
no? Yes? Is it that one? Is that one? That's the one I'm doing up here. So let me do another one of those. So if I had y to the 8th over y to the negative 3, right? You either do the rule, which is, what's the rule? When you divide, you, yeah, they're equals. When you divide, you subtract the powers. So minus a negative 3 is actually plus 3. Do you guys see how those two negatives canceling is the equivalent of pulling this dude up? The two negatives cancel, so it becomes positive. What happens to the power when I pull these three y's up? It becomes positive because the negative did its job once it's up top. So those two minuses becoming a plus is exactly that thing happening. When I pull it up, it becomes a positive. Why does it become a positive power? Because the negative did its job. Right? You wouldn't say that 9 divided by 3 equals 3 over 3, right? What's wrong with that? Why is that over 3 still there? It should be gone because it did its job. So when you move something with a negative power, the negative power goes away because it did its job. Why would it still be? It'd be like, oh, we never stop. I'm up, I'm down, I'm up, I'm down. You never get past the first problem. No, do you guys see what I'm saying? So it's got to eventually just be happy where it's at. I mean, get north.
Okay.
Yeah.
You have one which is x squared as a fraction over a negative 2.
Yeah, that's the same problem.
Okay.
Same
Oh,
problem.
that's the same problem?
That's the one.
Because-
I put a number in there, so if I had like, again, I don't
Well,
want
there's
to
a
do.
number on the bottom, so.
Yeah. So let's say it's d squared over 5d to the negative 8.
Yeah.
What flips? Which ones? The 8d's, right?
So it's like 1/5, right? Over.
Sure, you could. Those go up.
Times.
Those stay there. There's no reason they would flip.
Right.
So this would be d squared times d to the 8th over 5, which is d to the 10th over 5. No reason for the 5 to go up, because it's not being raised to a negative power, is it? Yeah.
So if I stuck a 1 on the top there, it's the same thing. 'Cause one
Same
times-
thing.
Okay.
Yeah. That's that one that we don't have to write. We know it's there.
Got it.
7x to the 0 power.
Okay, so what about 28m to the 0 power?
28.
Everybody had this problem and nobody had this problem. What's being raised to the 0 power?
And
What's being raised to the 0 power? M. So read this, then it'd be 28 times,
1.
what's m to the 0? 1. Yeah. How is that different from this problem? Those are different. Those problems are different. Is there anything here that's not being raised to a 0 power? Is there anything here that's not being raised to a 0 power?
no.
Guys, stay with me. Is there anything here that is not being raised to a 0 power? So the whole damn thing becomes 1. Here, there is something that's not being raised to a 0 power. Why would it change? What? Trying to get about it? How do you like it?
No, that was a flight. That was a flight. That was a flight. That was a flight.
Shut up, teacher. That was funny.
It's annoying. Oh,
Yeah,
there's
see?
this too.
They're trying to get out of the rain. There he is. All right. Anybody else? Yes.
I also have a question from
I'm not
exercise 5.8, number 25.
Okay, all right. We're gonna get back into that.
Oh, okay.
The long division, and then we're gonna do synthetic division. Okay. So do we have anything else from homework before we get back into where we left off, besides that one? Oh, good, I already started. Anything? Homework stuff? When's our next test? Next Thursday. So what's going to be on? I actually don't know yet. We'll find out. Depends on how far we get by Monday. We'll know on Monday how far we're going to get. Yeah. Okay. So here's where we left off. You guys all right? Some weird shit going on. Alright. Okay. So we all, oh, you're getting ready already. We all really enjoyed this. I'm going to do a problem. I'm going to do it with long division. And then I'm going to show you how this shortcut called synthetic division, how it works, and show you the connection. Then I've got a little handout that's got more examples on it for you to reference. Oh yeah, I want to. So let's do. Do that. Oh, I don't have to do that. Let's see. Divided by x minus 2. What's going on today, man? I like this a lot better than a classroom full of people on. Everybody all right? You all right? What?
Because it's recorded. Your reactions are funny.
Oh, okay. All right.
You just
All
make
right.
the class a little more entertaining.
So, the fantastic thing about this problem is I already know how to do it.
Got some chopsticks. Want more of those?
We did a couple of long division of numbers, and they work the same way. Maybe I shouldn't face you. All right. So I mean, isn't this how you set it up? Now somebody else showed me. Yesterday showed me the way that they learned how to do it, because not every country does it the same. There are other ways to set up a division problem, just organized in a different format. So I mean, I could try to work with you on how to make this, or you can try to figure out this, the way that this works. You gotta let me know one way or the other, if you're in that boat. So how do I start this thing off? What do I do? Yeah. So I could say x goes into this how many times, but it's equivalent and easier to think about if I say x times what is this? What do I multiply x by to make it 5x cubed? 5x squared. And again, let me just put a little example down here. What you got? It don't matter. 4 goes into 9 twice. That's a good first number to start with, right? And then you do 2 times 41. Then you take the 1 into account. So here, x times this is this. Next step, multiply this by these, right? Because what would the next step be here? 2 times 40, 2 times 1, right? Do it to both. So 5x squared times x. I mean, that's kind of like duh. That's there because that times this is this. So that first piece should always cancel. If it doesn't, you did something wrong. And then 5x squared times negative 2 is 5x squared times negative 2.
Negative 2x squared.
5x squared times negative 2. Negative 10 x squared. I like it. And then what do I do? Yeah, because what would the next thing be here? That's 2 times 41, and then we change it to negative. So I'm going to change these signs. So every step for this is the exact same as that, because what are x's? What are they? What are our variables? Unknown numbers. So they got to act the same way that numbers do, because that's what they are. They're numbers. They're going to act the same way. So what do I get here? 3x squared. Bring down the 4x. I like it. And then you do the same thing. X times what is 3x squared? 3x times x is amazingly enough what we just said. 3x times negative 2 is. And then you change the signs. Die. 4 and 6 is 10. Neato. X times what is 10x?
10.
So then 10 times x is what we just said. 10 times negative 2 is.
Negative 20.
And then you change the signs. I really want you to know every step we do is the same step as it was before. It has to be. The process of math doesn't give a shit what's in there. We care because now it's like a bunch of x's and holy shit, but it's the same steps we would have done before. Those die. You don't put big ass R 22. What do you put up here? Plus 22 over x minus 2. That's the answer. That's so exciting. Students love this because it's just so long. If I put another couple terms here, hello, turn the paper this way, maybe, or tape some more paper on, right? So this is gross. So we developed a better way. A lot of this shit is unnecessary. Why do I keep writing this down when I know it's going to die? Right? And then I know the x's go from cubed to squared. I don't need to keep writing them. Sort of like, again, this is the only connection that has with matrices, but it's a huge one. Get the variables out of the way. What matters most is the numbers, the coefficients. Yes, ma'am?
Could you please repeat again why you changed the sign next to 10x squared?
Oh, okay. You ready? All right, so 2 times 40 is 80. 2 times 1 is 2. And then what do I do with 80 and 2? I change the sign. I subtract it. So I subtract 80 and 2. So here I'm going to subtract 5x cubed and negative 10x squared. So their signs both change. So really, what I'm doing is subtracting this number.
I see.
But instead of doing that and having to write it again or something, I just say the negative is going to distribute. You just change all the signs, right? Okay. So here's how synthetic works. Now this is going to be a little bit quicker to pick up on. Matrices, of course, some of us are still picking it up. I understand. This is going to be a lot quicker to pick up on. You're not going to get it immediately, but let's just see how this goes. I like doing a problem like this and then immediately shortcut because then you can see the connections. So here's what we do. So again, the whole idea is this doesn't really matter. Now synthetic requires us to divide by 1x plus or minus something. That's the only thing synthetic works with. So synthetic requires you to divide by x plus a or minus a or something, like x plus 7 or x minus 6 or something. You guys with me? So I told you synthetic only works in certain situations. Synthetic, by the way, is the name of the division that's the shortcut to long division. Okay, how we doing? Okay. Has nothing to do with synthetic oil or something that I know of. So here's the idea. The x's don't matter. What matters, of course, is that these are in the right order. Is that cool? Sort of like the matrix. Before you make a matrix, you got to make sure everybody's lined up the same letter. So here, I got to make sure this is the right order. And it is. Right? So the variable doesn't matter or shit now. So I'm going to put like a negative 2. But what I'm going to do, instead of having to change the stupid sign every time, let me change this guy's sign right now. Right? Now watch. So 5 times negative 2 is negative 10. Then what do we do? We made it plus 10. So why not just make this a positive 2 at the beginning? Instead of changing the sign every time, let's make this a positive 2. So I change the sign once at the beginning. So that's why I put a little 2 there. Just go with me on the format. You'll see in a minute. I call that the penalty box, even though I don't watch hockey, really. So we just put them in the penalty box. So if it would have been x minus 3, I would have put a little 3. If it would have been x plus 7, I would have put a little negative 7. I changed the sign at the beginning, so I don't have to do it every damn time. I like it. Now list the coefficients for me of the thing I'm dividing by into. 5, negative 7, 4, 2. If we were missing something, if there were no x's, I'd have to put a 0 where the 4 is. I need a placeholder for that. But we have everybody represented. Now, I really want you to understand why this works. Why was the first part of my answer a 5? Because there's a 5 there, right? If it would have been 7x cubed, this would have been a 7. Ooh, right? Because this is a 1 here. What do I multiply 1 by to make it this? Well, I multiply it by whatever the shit this is. So this, I'm going to write here, is going to be the answer. Stay with me now. This is really not bad. It's just that you've never seen it before, so it's really, really nice. So what I always do is I just bring this guy down. He is part of the answer. And he is part of the answer, isn't he? Now, what did we do to get this 10? We did 2 times 5, right? Mm-hmm. We did negative 2, but we're going to change the sign. So you bring this down. 2 times 5 is 10. Negative 7 plus 10 is 3. Do you see how that's the step?
Yeah.
So then you keep doing that. You keep doing that. This guy comes down and gets us started. 2 times 5, 10. Add. 2 times 3 is
6.
Add. That's this. So I'm eliminating. See, am I even writing anything about this shit? Of course I'm not, because it's going to die. So why keep it there? Right? And then 2 times 10 is 20. Add. Whatever's at the end is always the remainder. Now, here's how you write the answer. What was the degree to start with? Third. I divided by something like x. So the degree should go down by 1. So that would mean this starts off as 5x squared. Now I bring the variable back in. So I took the variables out of the way, and now at the end I'm going to bring them back in. 5x squared plus, now they go down by 1, 3x, become a 3. Plus 10, and that's the remainder term, so it's going to be over. Crazy shit.
Why did you bring it down again?
I don't know. Oh, which one, sorry?
When you were at 3x cubed, then you went down to x squared.
Oh, if I take something x cubed divided by x,
I see.
it's going to go down.
Okay.
So like if I said, take 1200, let's just make it more messy, 1271 divided by 102, that's 1,000 up here. So on the level of 1,000.
Yeah.
When I divide by 100, now it's going to be on the level of 10. Right? I can tell kind of how big the answer is going to be, the degree of the answer, right? Based on how big each one of these is. Well, this is a third, this is a first, so the answer should be second power,
right.
Second degree. I'm going to lose an x from everybody. Let's do a couple more real quick in succession. We're not going to do long division. Let's just do some synthetic.
So that only works if there's no coefficient?
It only works if I have something over x plus or minus something. So there's a 2 there, too bad. If this is squared, too bad. There are ways around that, but they get kind of messy. So it only directly works if you divide it by x plus or minus something. It's hardwired for that. That's why it's so easy. You guys might not agree with me totally yet. But wasn't that a shitload easier than even if you don't quite get this yet? Okay, so let's try a problem, another one. So what you look for is the top in order. Is it in order? But what is the one little thing to notice? There aren't any x cubes. So in that place, we better put a 0. Now I really want this, watch this. If I divided 1098 by 72, right? Doesn't it have built into it a 0, meaning I have no hundreds? So to be fair, to make this work, I have no x cubes. I better put a 0 there to mean I have no x cubes. The same reason. I need that spot to show up. I can't just say, oh, 1098, let me just write it like that. Well, that's going to be a little confusing. How many people expect to show up? This many. Oh, shit. Right, so thank God we have a symbol for 0. What are you doing over here? About to try to erase stuff. All right, so what am I going to put in the little penalty box for this guy?
-1.
-1. I really want it to make sense. We're going to build into this whole process. We're going to take care of what's annoying. What's really annoying is having to remember to change the damn stuff. Let me do it first. Bam. In fact, what's a quick way to do it? What makes this 0? -1. It's really just the opposite of this, but still, that's another way to look at it. So what are the coefficients I'm going to put up here? 7, 5, 0,
-6.
x to the 5th, x to the 4th, x cubed. No x cubes. Keep going.
-6.
All right, so let's do this together. What goes down? What goes here? Yeah, that gets me started. Just pull the 7. Bam.
Oh, just pull it.
Pull it down. And then, yeah, -1 times 7 is -7. Add. -1 times -2 is 2. Add. Multiply.
12. Oh, 8.
All right. Multiply, right? Multiply. Bam. Add. Multiply. Add. Multiply. Add. So I multiply here, and then I add. Multiply here, I add. Multiply, multiply, add. So forth. Keep doing that over and over. And if you look at a long division problem, you'll see that's exactly what you're kind of doing. That's the most important steps are when you multiply the thing you put up here, you multiply it, and then you add these things together. Those are the 2 most important steps, and that's the only shit that shows up here. Because that's the most important thing. Yes, ma'am?
I thought you said you had to change the sign.
Totally. It was a positive one, and now it's a negative one.
I was looking at the remainder, -1 up there.
No. It's you change the sign of what you're dividing by.
Okay.
Yeah. Okay.
So the first 7, you don't do
Yes.
nothing with, right? You didn't multiply by anything, you just brought it straight.
Yeah, that's what got us started.
Got it.
So now, what's the same? This is the answer, but it's not in the right format. It's just a bunch of freaking numbers. So what's the format? 7. Good, because it was a 5th, so now of course it's a 4th. Because I effectively divided by x. -2x cubed plus 2x squared minus 8x plus 10. This guy, of course, is the remainder term, so it's going to be minus x plus 1. I like it. Can you imagine how long this would have taken doing a long division? That would have been even longer than the one we did earlier. Whereas this way, I add on more and more, it really doesn't make it that much longer. Because it's a bunch of multiplying and adding, which is easy. Relative to subtracting and dividing, right? Let me give you this handout so you guys can stare at it for a minute. Some of these are in a different color, which is neat. My office mate left different color stuff in there, but oh well.
So the Plato or Einstein come up with
What's that?
Who came up with that one thing?
Several people kind of did actually. That's why it doesn't have a name attached to it. So I've got a long division example at the top, which I redo at the bottom using synthetic, and in the middle I've got a synthetic division example. Okay. Trying to really splay out what happens. You set it up like this, and have little arrows. Hopefully that's helpful. No, yes, maybe so.
How do you get the zero? I couldn't get that part.
How to get the what?
How do you get the zero? I get
So, if this is x to the fifth, let's just go down by place. So this should be the x to the fifth place, the x to the fourth place, the x cubed place. Well, how many x cubes do I have?
none.
None. So that's why it's 0. It's just like the thousands place, the hundreds place, the tens place, the ones place. This means I have no tens. We invented 0 to be a placeholder for what we don't have any of. So it's got to show up here. I don't have any x cubes.
You got it.
So this has to be in order for this whole thing to work. So if I'm missing somebody in the middle, I've got to represent that place with 0. Same thing with long division. You have to do the same thing.
Old English was like that, 70, they would say 70 plus 2. They wouldn't say 72, they would.
Oh yeah, exactly.
You know, 2 bits, they would.
So it'd really be in your face that you have a 70
Yeah.
and a 2. I like it. 2 bits, of course. Shave and a haircut. 2 bits. All right. Oh, you showed it, old man. All right. Leave us. So let me let you guys try a synthetic on your own. I'll give you one that's got all its parts here. Let's see. Let me see. Oh, yeah, that'll work. I'm trying to make it not too evil. Yeah, okay. We'll see what happens. See if that's true. To make sure everybody's got this getting set up correctly. What goes here?
-2,
-2, I like it.
4, 5, -7, -1, plus 2.
Yeah, because I wasn't missing anybody, right? Oh, dude. He's almost dead. How are you doing? You're almost short of. Don't do it, kids.
Bring that one.
Okay, so, and I didn't have to worry, I had everything there, right? Fourth, third, second, first, no x, right? The 0th power, to be honest. X to the 0. I don't want to forget. So yeah, started off by bringing that down.
And you multiply that, it's
-2.
-8.
Good, -2 times 4 is -8.
Yeah.
Add them, -8 and 5 is -3. And then
6.
multiply,
Negative
add.
2.
Multiply, add. Multiply, add. Now, I want to make it really clear. I wish I could take credit for going in evenly. I didn't consider that. That's kind of a coincidence. I just wanted to come out decent without like getting -412 or something. So that's kind of nice. What the hell does that mean?
No remainder.
No remainder. So when an even, can somebody go further than that? What does that really mean? What's the answer? Let's first write down what the answer is. What's the answer?
4x cubed.
So if something goes in evenly, x plus 2 went in evenly. That means that x plus 2
There is no more x plus.
times this equals that. That's what that means. So when it goes in evenly, what you've actually done is you have factored this. We just figured out, let me write this out explicitly. All this I'm talking about right now is a little bit extra stuff, sort of. So what we just figured out is that 4x to the fourth plus 5x cubed minus 7x squared minus x plus 2 equals x plus 2 times 4x cubed minus 3x squared minus x plus 1. That's what we just figured out. And if you go into pre-calculus, you're going to use the shit out of synthetic division. You're going to love synthetic division because already you should sort of like it, at least. Like, yeah, I like that. It makes things so much quicker. But it's actually, we haven't even gotten into chapter 6 yet, that's factoring. But synthetic division is actually a really nice way to try to factor things. So we just took that number, whatever that number is, and it factors like this. In fact, let me go further. Because you know I always do. I'm already past the part of the problem that you really have to worry about yourselves. You with me? I passed it by. What is x? Anything I want it to be. Except in this case, I can't use negative 2. I can't use negative 2. Right? So let's use 2. X could be whatever I want it to be. So what does this statement mean? Whatever this number is, it equals this number times that number. That's what that says. Well, let's check it. What if x is 2? What number is this? Well, this would be 4 times 2 to the fourth. 2 times 2 times 2 times 2, that's 16. Plus 5 times, what's 2 cubed? 2 times 2 times 2, 8. Minus 7 times 2 squared. Minus 2 plus 2. That's what this number is. So what number is that? That's going to be 64 plus 40 minus 28. And then these cancel each other. Is that cool? And so I get, what do you get, Jeff? I don't know. This is 12. So that's going to be 76. Okay. You can check me on that. You never know. Now, if x is, so if in general, this should equal this for everything except negative 2. So if x is 2, this is 76. If x is 2, what's this? If x is 2, what's this? 4. And then I get here 4 times 8 minus 3 times 4 minus 2 plus 1. Because x is 2 for this whole thing, right? I could have picked 3. I could have picked 11. I could have picked 18 billion. Doesn't matter. So you're going to get 4 times, got it. 32 minus 12 is 20. Minus 2 is 18. Plus 1 is 19. What's 4 times 19? 76. So this statement means no matter what you pick for x, this equals this times this. I just picked 2 to show you it's true. You could pick whatever you want to. And to be really honest, you could pick negative 2. It's just going to be 0. It's not going to be very interesting. See how you put a negative 2 there? It's going to be 0. All right. Yes?
If there isn't a 0 in the remainder, it's not factored all the way?
If there's not a 0 in the remainder, that means that this does not factor as this times something. So then you could, if you're trying to factor something, you would just pick something, you would just guess something else and try it. And synthetic is pretty quick to do, so you could try a lot of things quickly. Okay, maybe. All right, so that's section 5.8, if I remember. Yes. I want to say this about section 5.9. Section 5.9.
I want to use synthetic motor oil from now on.
I got a Honda, I got to. I have no choice. They can't handle anything else. So 5.9, we're going to make it extra credit. Just so we can get into factoring and get some of that stuff going on. 5.9 though, let me just do one problem with you guys, just to show you what it's all about.
When you say extra credit, is it like doing the homework or something?
Yeah, so the way I do homework extra credit is if you do some extra credit for homework, I'm going to add it onto your homework grade. So if you get all the homework, you have 100 homework grade, that means you'll have a higher than 100 homework grade. If you do some extra credit homework, yeah. Or if you've got some that you didn't do or you didn't correct, it takes the place of a couple of those. It's up to you. You don't have to do it. Just remind me real quick. Just remind me. What is f of 2?
3.
Yeah, it'd be 5 times 2, 10, minus 7 is 3. I like it. What is g of 2?
0.
0. All right. So let's do, what is f of negative 1?
-2.
No. So it'd be 5 times negative 1
12.
minus 7,
Negative 12.
negative 12. And what is g of negative 1?
3.
Yes. 4 minus 1, 3. So, all right, that's all old news, right? All of that. What do you think then about this question? What does it look like the functions are doing with each other?
Multiplying.
Yeah, they're multiplying with each other, right? So another way to write this is f of 2 times g of 2, which really just becomes this and this, right? What's f of 2? 3. And what's g of 2? 0. So what's f times g of 2? 0. What about this question? F over g of negative 1. So what do you think that means to do? So f times g of 2 meant take f of 2 times g of 2. What does f over g of negative 1 mean? Take f of negative 1 divided by g of negative 1. What's f of negative 1? We just did it. Negative 12. What's g of negative 1? 3. So what's f over g of negative 1?
-4.
Negative 4. So really at the heart of 3.9 is, if I see f sitting next to g, I multiply them. If I see f over g, I divide the outputs. If I see f plus g, well, that one's 2 in your face. I mean, you just add them. 3 and 0. F of 2 and plus g of 2. If you see f minus g, you subtract it. All right, that's all I'm going to say about 3.9. It's extra credit, but it's not difficult. So if you can find time, you can do it. We're going to take a little baby step into chapter 6. And then we'll head out. All right. So a lot of what we're going to do, there's going to be, in chapter 6, I like to do a few group work assignments. I don't like other people. All right. Because I want you to kind of see why it just makes sense what we do. Factoring, variable expressions, people sort of give up on it before we start. But if you can multiply two things together, you should be able to figure out a way to rip them back apart, right? So it's just like 7 times 8 is 56, and then say how factor 56, you can say one way to do it is 7 times 8. Right? There's a lot of different ways to factor it out, right? The nice thing with polynomial expressions, there's really just one way to factor them. But help me out. This isn't factoring. This is just multiplying. So what do you get when you do this?
24x squared minus 20x.
Now, of course, now let me say something remarkably stupid sounding. Don't these both have a 4x in them? Do you see what I mean? Of course they do, because that's what we gave both of them, isn't it? If I didn't have this here, could you see that that's true? What's 24 and 20 have in common? 4. What does x squared and x have in common? They both have an x. He's got 2. Good for him. He's only got 1. Shit. So I call this, well, I don't call this. It's called GCF. It's called greatest common factor, but I call it the fair tax man. He won't take more than he got. So what can I take out? The numbers I can take a 4 out of. He can give 2 x's, but he can only give 1. So you're only going to take 1 x. So you'll take all the shit you've got, but he won't take more than that. Oh, thanks, taxman. 6x. Yeah, this will be 24 divided by 4. 6. See how when you multiplied it and you multiplied it in, when you distribute and you multiply. So when I undistribute, when I do this, I divide it out. 24x squared divided by 4x is 6x. 20x divided by 4x. Yeah. So just to do one straight up, if I had 16a cubed minus, what you got, Jeff? 20a. Yeah, you look at the numbers. What can come out of the numbers? 4. What can comes out? What can comes out? What can comes out of there? An a. So what's left in this term?
4.
Yeah, 16 divided by 4 is 4. I had 3 a's. I took 1. I have 2 left. Minus? Yeah, 5, because I took that poor a away. How do you check it? You multiply that shit back in. That's supposed to multiply to be this, right? That's how you check it. Now, GCF is one of the easiest forms of factoring, because it's just, like I said, it's just undistribution. So if you can distribute, you should be able to undistribute, right? Does that make sense? Me saying that weird shit? Okay. So we call it GCF, just so it doesn't sound like a completely made up word. Greatest common factor. Biggest thing that everybody's got. Okay, so next time, I think the next test, we're going to know more on Monday, but I'm pretty sure we're going to end up going up through 6-2.
Isn't Monday is like Columbus Day or something?
Is it?
It's a holiday.
No, it's still at school though.
That ain't a holiday.
Yeah, I put all the
It's
holidays
a government holiday.
on the homework sheet. We like to pretend like we're not really fully government sometimes. Let me stop this one. Sorry.